This is section 8-9. And so here's a picture of a fish eating another fish. It either choked and died or died in the process of eating the fish. So sedimentary rocks preserve evidence of past depositional environments. So the fact that there's fish here, I know that this sediment was deposited, and the fact that it's a clay or siltstone, it was deposited in a lake. It's not going to be deposited out in the middle of a Great Plains, or most likely not in the ocean, because we don't really have that many deep sea sediments preserved and uplifted onto the continent. So you usually don't get fossilization in those situations. So this is probably from a lake, based on the type of sediments and the fact that you have fish. So because we get fossils and other indications, which I'm going to talk about sedimentary structures in a little bit, but in this section I'm going to talk about the different depositional environments that can be found. Okay, so here are continental environments of deposition. Over here, this is showing you a glacier or glacial deposition environment. In this case, you're going to get poorly sorted, angular to rounded grains. That's what you're going to find in the glacial depositional environment. This next one is a desert. Desert, you're going to get well sorted, rounded grains. They're going to be well sorted because they are windblown. Over here, this is an alluvial fan. We haven't really talked about alluvial fans yet, but alluvial fans form in dry environments. When it rains, the mountains erode, they flow down, they hit the valley, and they deposit these large mounds of sediment. And that's what the alluvial fan is. So they're found in dry environments that only rain sporadically. And this right here is the alluvial fan. Alluvium is just weathered material, and it makes this fan shape when it hits the flat valley. So this is going to be arid and dry. So these are going to be generally poorly sorted and angular, or mostly subangular to subrounded, because they're not being transported very far. They're only going a short distance. Down here is a stream. A stream is just another word for river. Any water flowing in a channel is a stream. Your stream is going to get coarse gravel and sand that is well rounded. Your floodplain, which is the area, so this is the stream, the area around it is the floodplain, is going to get finer sediments, which is your silt and clays being deposited on it. This is wetlands. Wetlands are very low energy environments. They're basically stagnant water. You get a lot of life, algae and other microscopic organisms living in them, so you get a lot of biogenic sediments, like peat. You also get clays and silts being deposited here because it's a very low energy environment. This last one is a lake. Lakes, you can get clastic, chemical, and biogenic sediments being deposited. They're teeming with life. You can chemically precipitate limestone. And you also get runoff from streams, which brings your clastic sediments. So all three different groups of rocks will accumulate in a lake. So next we're going to move on to coastal environments. So this is a delta. That's where a stream enters into a body of water. A delta will form because the energy stops and the stream dumps its sediment load. So generally you get clays and silts and some sands. Can also have a high amount of organics. This next big one is a beach. Beach has a lot of wave action on it. You're going to get coarse sand that is well sorted and rounded. You get all that wave action pounding onto the sand. You get a lot of abrasion occurring. This is a barrier island. So this right here is the barrier island. This is the waves breaking on it. Behind the barrier island, you get a lagoon. It's much lower energy. But the barrier islands are where the waves are breaking. So generally, you get coarse, well sorted, rounded sand. Over here, this is an example of a lagoon. This is going to be low energy. So you get mud and silt. You can also have a large biogenic component. And this last one is a tidal wetlands or tidal flat. Once again, this could be low energy environment. You're going to get high tide, water is going to flood in, and then water is going to flood out, so you're going to get silt and clay. You're also, because there's so much vegetation, you're going to get organic sediments, and there's a lot of things living here, so you can get skeletal fragments. Okay. One thing to note about beaches, most beach sand is made out of quartz. However, because everything else has been weathered out from the mountains by the time it gets to the coast, all you have left is the quartz. However, in certain areas, like the Bahamas and the Caribbean, where you're on a limestone platform, all you have is limestone. So your sand is actually made out of limestone. So when you go to the beach there, it's actually limestone sand and not quartz sand. So sand, remember, is just the size of the grain. It can be made out of anything. If you go to Hawaii, they have black sand because your basalt is eroding and it's not being transported very far. The olivine, the pyroxenes, and all the black minerals haven't been weathered out yet. So you have a much different composition of sand than you do along the East Coast. And even along the Gulf. So sand, remember, is just the size and the sorting. The composition of the sand is dependent on the source rock and how much weathering, transport, how much time has passed, and so on and so forth. Okay, so marine environments. This is a reef. This is actually a fringing reef. Here was a volcano or an island, and the reef is fringing around it. So this is the reef system here. So this is going to be biogenic, because the reef system builds up over a long period of time, and it's mostly limestone. Next is the continental shelf. Continental shelf has a wide variety of sediments. We talked about this in chapter 21, the origin of the sediments, but you can have classic, chemical, or biogenic sediments accumulating on the continental shelf. This is the continental margin. So this is everything beyond the shelf, the slope, the rise, the deep sea, the abyssal plains. That's close to the continent is the continental margin. So once you get out to the deeper sea, then we're going to talk about deep sea in a second. But this, once again, is going to have a wide variety, biogenic and clastic sediments primarily. This is the deep sea, which once again, we talked about this in chapter 21. It's primarily going to be clastic that are aeolian derived from the wind blowing off like the Sahara. It blows the particles off. They silt and clay-sized particles off the coast for thousands of miles. Eventually the wind dies down and it settles down into the deep sea. So you're going to have a large component of clastic, but you're also going to have biogenic as well. And once again, this was talked about in chapter 21, so I'm not going to go reiterate it.